Welcome back to the deep dive. Today we are tackling what is arguably the biggest, most profound question that the success of modern science really forces us to ask. Can science explain all of reality?
It truly is the ultimate inquiry. I mean, every curious mind eventually lands there because the evidence of scientific success, it's just overwhelming.
It is.
The sources you share document it so well, it changes our lives so fundamentally that you start to think, maybe it can explain everything.
That's the perfect framing for this. Let's start right there with that transformative power, because it really is the bedrock of this whole debate.
Okay.
I mean, think about the immediate, relatable examples. You, the listener, you probably have a smartphone in your hand or your pocket right now.
Oh, certainly.
And that one object, it puts the sum total of human knowledge, basically the Library of Alexandria, right into your immediate access.
And that's not magic.
No, it's the highly predictable, repeatable result of applied quantum physics, material science, and, computer engineering.
And you can extend that beyond just convenience. Think about public health.
Right.
Modern vaccines didn't just appear. They are the result of rigorous biological and epidemiological research that has, within 2 generations, completely reshaped global mortality rates.
And eradicated diseases like smallpox.
Completely. Or just
Yeah.
look up at the sky. We have planes crisscrossing the globe, a dense network of satellites orbiting the Earth, delivering everything from GPS signals to weather data. It's incredible.
And beyond the sheer technological output, which stunning in itself, is the capacity for prediction.
Yes. That's the real mark of understanding, isn't it?
It has to be. Science gives us this almost unbelievable accuracy in charting natural phenomena. We can predict the precise minute of a total solar eclipse centuries from now.
Centuries.
We can model massive weather systems. And with things like particle colliders, we can predict the behavior of subatomic particles that are, fundamentally invisible to us.
This capacity to understand the universe, from the largest structures like galactic superclusters all the way down to the smallest known components of matter.
And then to shape that understanding into technology.
Exactly. It is nothing short of staggering.
Yeah.
And when you have a tool that powerful, that reliable, the temptation is just intense.
Right. When a method is that successful, it's completely natural for us, for you, the listener, to wonder if that tool is the only tool you need. If science has unlocked the secrets of the cosmos and the complexity of the human genome, what fundamental questions could possibly remain outside its grasp?
And that right there is the core mission statement for this deep dive.
Yeah.
We're going to explore the precise domains where science excels, and then define what philosophical traditions and intellectual boundaries suggest might lie fundamentally beyond its empirical reach.
And then examine how different viewpoints, from philosophy to religion, respond to this idea of a complete scientific picture of the world.
We need to define not just the power of science, but its ultimate jurisdiction.
Okay, let's unpack this enormous topic, and I think we have to start with the very definition of the tool itself. What is science?
To understand the limits, we first have to really appreciate what science is, because so many people mistakenly confuse it with just, a list of facts or cool gadgets.
Right, technology.
Exactly.
Right.
But the sources all stress that science is fundamentally a method. It's a dynamic, self-correcting community practice.
It's a mechanism, really, one that's been designed and refined over centuries for reliably finding truths about the natural, observable world.
And the rigor of its core components is why the results are so robust.
It all starts with observation and experiment, right? Asking a very precise question about some measurable phenomenon.
Exactly. And from that observation, we start to build these conceptual structures. First, a hypothesis, which is really just a testable proposal.
An educated guess?
A very educated guess. And then theories, which are these comprehensive, highly verified explanations for huge swaths of natural phenomena.
But the crucial step, the real acid test, is making testable, quantifiable predictions. That's the hinge, isn't it?
It is absolutely the hinge. A theory about, say, plate tectonics isn't just a good story. It must predict where future earthquakes are likely to occur, and maybe even with what magnitude.
And if it predicts correctly, the theory gets stronger.
But if it consistently fails?
It has to be revised or, thrown out.
And the true genius of the system, I think, lies in the social mechanism for weeding out the flawed ideas.
You mean peer review and replication?
Peer review and replication. You can't just stand on a soapbox and claim a discovery is true. Other scientists, who are often very skeptical, must be able to independently verify your exact methods, run the experiment themselves, and get the same result.
That community accountability is really the engine of scientific reliability.
It really is. And that means, fundamentally, that the whole scientific enterprise is constantly provisional.
What do you mean by that?
It demands a willingness to revise our most cherished theories when new, compelling evidence changes the picture. We move from Newtonian mechanics to general relativity, not because Newton was wrong.
Right. His laws still work for sending a rocket to the moon.
Exactly. We moved because Einstein provided a better, more encompassing explanation that accounted for subtle deviations Newton's model couldn't explain. Science is a search for truth, not a defense of dogma.
And the scope of this method is key. It's precisely tailored for the natural world, for patterns that can be measured, phenomena that can be modeled, and processes that can be predicted, at least probabilistically. It's the perfect tool for quantifiable, empirical reality.
And that focus is why it has been so spectacularly successful across these huge domains. It explains the entire physical cosmos, from the largest structures we can see down to the smallest fluctuations in the quantum field.
It explains the complexity of biological life, the history of species through evolution, and, increasingly it's informing our understanding of the brain and many aspects of our own behavior.
But here is where that human tendency toward universality creates a danger.
Okay.
When you have a tool this effective, there's a massive intellectual temptation to elevate it beyond its intended role.
To make it the only tool?
To make it the only tool. To create a belief that says, if something is real, science either has explained it or it will explain it one day. Anything outside that scope isn't really worth discussing.
And that elevation, that leap, leads directly to what philosophers call scientism.
Right.
And it's so vital to distinguish it from just being pro-science. Loving and respecting science is necessary. Scientism is a philosophical claim that goes way beyond that respect.
Precisely.
Right.
Scientism is the belief system. It asserts that science is the only real path to knowledge, the only legitimate method for acquiring truth.
So it takes the successful scientific method and tries to impose it as a universal definition of what even counts as knowledge.
The universal epistemology, exactly.
And if we really were to adhere to strong scientism, the implications for the vast spectrum of human inquiry are immediate and profound.
They are.
Anything that you can't study scientifically, anything you can't put in a test tube, measure, or model probabilistically is either relegated to the category of the unknowable or worse.
It's dismissed as potentially not real in any objective sense.
This is where we see the downgrading of huge areas of human endeavor. Questions of ultimate meaning, the existence of God, objective moral value.
They're often dismissed as just confused or meaningless or purely subjective emotional expressions.
So art, literature, philosophy, in this view, they're reduced to things we do for comfort or pleasure.
But not genuine sources of knowledge.
Not at all. Now, the strength of scientism, we have to acknowledge, is its rigor. It insists on evidence, clarity, testability. It's a powerful antidote to superstition and just, unfounded belief.
Absolutely.
But I want to zero in on the major philosophical criticism that you highlighted in our sources, because it's almost a self-defeating argument.
Yes, the paradoxical critique. It's fascinating. The central problem is this: the foundational claim of scientism.
Only science gives real knowledge.
Right. That statement is not itself a statement derived from scientific methodology.
You can't design a controlled, testable experiment in a lab to prove the statement that only lab experiments yield truth.
You can't. It's an inherent paradox. The rule that defines the entire system, the jurisdictional boundary, is established by a philosophical assumption, not by empirical observation. To assert scientism, you have to first accept a non-scientific premise.
It's like a scientist using a measuring tape to study the universe. A scientist says everything that is real must be measurable. And a philosopher then asks, did you use the measuring tape to measure the authority of the measuring tape itself, or did you just assume it was the right tool for the job?
That's a perfect analogy. The claim of totality is an intellectual leap that the data itself just cannot justify.
And that highlights the crucial philosophical boundary line drawn around this scientific territory. It's the first major limit we encounter.
A crucial distinction for our listener, recognizing the difference between the immensely successful tool, which is science, and the grand, unsupported philosophical claim, which is scientism.
Okay, so let's pivot for a second, because before we continue to define the limits, we have to fully appreciate the enormous explanatory power we're even talking about.
We have to give the method its due.
We do. We're moving from definition to a kind of high-performance review of scientific capability.
And the performance is extraordinary. It's extraordinary precisely because the scientific method is perfectly optimized for the two things it does best, dealing with the quantifiable and tracing causal mechanisms.
Anything you can measure?
If you can put a number on it, it falls into science's domain.
Let's just look at the sheer scale of the domains of scientific power. You can start with physical processes. We understand the cosmos not just through, classical mechanics of planets moving.
No, we use the profoundly non-intuitive framework of general relativity, which predicts the bending of space-time itself around massive objects.
And that's a perfect example. General relativity isn't just a conceptual breakthrough. Its predictive power is staggering.
Staggering. It allows us to calculate how light bends around a galaxy. It was essential for the recent detection of gravitational waves, ripples in space-time, a phenomenon predicted a century before we could even detect it.
That is immense explanatory power over the physical world.
It is.
And that precision extends right down into biology. We can map chemical reactions down to the single molecular bond. We can trace the history of life through evolution, not just by looking at fossils.
No, not anymore. Now we use genetic sequencing to map relatedness and estimate timescales with startling accuracy.
And on the molecular level, think about tools like CRISPR gene editing.
Right.
Science has moved beyond just understanding genetics. It now allows us to precisely edit the code of life itself.
Which gives us immense control over biological systems, demonstrating an understanding of causal mechanisms down to the base pairs of DNA.
Which means science is undeniably the king of causal mechanisms. It excels at determining how things happen and, crucially, what causes what.
This is where its public health and policy relevance is just off the charts.
Take the simple example of epidemiology. Science established the causal link between smoking and lung cancer, not by some philosophical decree, but by rigorous observation, correlation, and mechanism tracing.
And it illuminates how incredibly complex systems like the climate work through feedback loops, energy exchanges, and quantifiable atmospheric chemistry.
The key here seems to be that science focuses on quantifiable patterns.
Yes.
Anything that can be measured, counted, modeled, and then predicted with a known degree of probability. If you can assign a number to it, science can often make sense of it.
And the output of that is incredibly valuable for just practical living. Science tells us a very specific set of things, how things happen, what tends to follow what, with what probability, and under which conditions.
It's a highly structured, conditional form of knowledge. And that's what makes it indispensable for building bridges, treating diseases, and flying airplanes. You mentioned 3 qualities earlier that characterize scientific explanations. I think they're worth repeating because they show why science is so reliable compared to other ways of knowing.
Yeah, they're key. First, they are public.
Meaning anyone, anywhere can test them independently. The knowledge isn't secret or reserved for a special few.
Exactly. Second, they are revisable. When better data comes along, the model is refined. And that's a strength, not a weakness.
And most importantly,
They are cumulative. Later findings don't typically invalidate the entire prior structure. They build on it.
like with Newton and Einstein.
Perfectly.
Right.
Relativity didn't make Newtonian physics useless. It just showed the boundaries where Newton's model ceased to be accurate at very high speeds and massive scales.
So it's a constant upward curve of increasingly detailed and accurate understanding of the physical world.
That's the ideal.
But this extraordinary success, this is precisely what sharpens the tension we're exploring today. Science is utterly brilliant at the how, the mechanics, the probability.
Absolutely.
But when you, the listener, ask, but why does this magnificent machine exist in the first place? The method hits a conceptual wall.
That is the transition point. When you ask a scientific question, you get a scientific answer, which is a mechanism.
Right.
The moment you transition that question into one of ultimate meaning or purpose or intrinsic value, you've moved beyond the input requirements of the scientific method. It's a magnificent calculating machine, but we have to choose the right numbers to feed it.
Here's where we move from the measurable into the metaphysical then.
This is where it gets really interesting.
Yeah.
When we go beyond what we can test, predict, or measure, we hit these deep foundational questions that many thinkers argue fundamentally defy scientific capture.
These are the profound questions that really define human existence, the ones that have shaped philosophy and religion since the dawn of conscious thought. Our sources detail a few specific categories that define this intellectual boundary zone.
The first, and maybe the most fundamental, is the question of ultimate existence. It's often articulated using the famous Leibnizian query, why is there something rather than nothing?
Okay, let's unpack that. Science, as we've established, can trace the physical history of the universe. It can describe the Big Bang singularity, the conditions of early inflation, the precise laws that govern the formation of matter and energy.
It can take us back to the earliest moments we can conceive of.
But as soon as we ask why those laws exist, or why those initial conditions were what they were, or just why existence itself is the default state,
The scientific method goes silent.
why? Why can't it answer that?
Because that question sits outside the physical parameters of the universe that science studies. Science requires an existing physical reality to observe and measure.
So it needs something to be there in the first place.
Exactly. If a theory tried to explain why anything exists at all, it would necessarily have to appeal to something non-physical or pre-physical, which is exactly where the scientific method, limited to the natural world, cannot follow.
Okay, so that's ultimate existence. Then there is the profound personal question of ultimate purpose.
What is the ultimate meaning or purpose of human life, if any?
Now, science can tell us a lot about biological purpose, right? The genetic drive for reproduction, survival, the continuation of the species.
It can, and it can explain the psychological function of goals and aspirations. They enhance social cohesion, individual persistence, things like that.
But those are all explanations of function and mechanism.
The how of survival.
Exactly. They aren't statements about ultimate intrinsic cosmic meaning. When someone finds profound meaning in, say, raising a family or creating a piece of art.
Science can explain the dopamine response in their brain. It can explain the cultural conditioning that led them to value that activity.
But it cannot empirically prove whether that meaning is true or just felt.
Right. Is it objectively real or just a useful illusion? Science can't settle that.
And finally, we get to the big metaphysical and moral questions.
Does God exist? And, just as thorny, is there objective moral right and wrong, independent of survival mechanisms and cultural preferences?
Can we find evidence for transcendent value in the physical world?
These questions resist resolution by empirical science for a few key reasons. The first one is simple. They are not easily convertible into testable, falsifiable hypotheses.
How would you even design a double-blind study to verify the existence of a non-material entity?
Or the intrinsic goodness of a moral principle. You can't.
It seems like it would require converting these complex qualitative concepts into quantifiable data points. And in that process of conversion, you destroy the very essence of the question.
You do. You can measure altruistic behavior, the fact of the action, but you cannot empirically measure the inherent goodness, the value of the action that might have motivated it.
Furthermore, these profound questions, they fundamentally involve values and perspective and meaning alongside the observable facts.
Yes. Science can furnish the facts. It can tell us how the brain reacts when we pray or what actions cause measurable suffering, but it can't tell you how to weigh those facts in a personal value system or a moral hierarchy.
And crucially, these topics touch so heavily on first-person experience.
What it feels like.
What it feels like to be an individual grappling with loss or transcendence, rather than just the third-person description of what happens in the physical world during those moments.
This leads us to a really important concept, the idea of the informed limit. We have to stress the nuance here.
Okay.
Science absolutely informs these great questions. Neuroscience reveals the complexity of consciousness. Evolutionary biology informs our understanding of cooperation. Cosmology informs our view of the universe's scale.
So science provides the necessary raw data, the facts on the ground.
It provides the facts on the ground, but it cannot fully settle the questions. These questions require philosophical or theological or purely personal frameworks to approach. Frameworks that are inherently outside the laboratory.
They require judgment, synthesis, and an appreciation for subjectivity and transcendence.
Areas the rigorous objectivity of the scientific method is simply not designed to process.
The method of science, because it's constrained by measurement, is masterful, but it's also deliberately reductive.
It has to be.
So when the question requires a holistic, non-reductive answer, one that includes the observer's inner life and ultimate values, the limits become pretty apparent.
Very apparent.
Let's dedicate some serious time to what is probably the single most debated boundary in contemporary science and philosophy right now.
Consciousness.
The problem of consciousness. This is where the third-person descriptive power of science hits its most formidable wall.
This is often referred to as David Chalmers' hard problem. But let's start again by acknowledging the magnificent progress. We've moved so far beyond phrenology. Modern neuroscience is just astounding in what it can correlate.
It really is. Science can perform these exquisite correlations between mental states and physical brain activity. We can watch a person experience pain, and we can see precisely which areas of the brain light up using fMRI or EEG.
We can track the neural network pathways involved when you recognize a friend's face or when you process a complex mathematical equation.
We understand the physical mechanics of the brain. Neurons firing, neurotransmitters crossing synapses, massive electrochemical reactions. A surgeon can stimulate a specific part of the temporal lobe, and a person might suddenly re-experience a childhood memory with startling clarity.
And this gives us immense understanding of the mechanics of mental function.
But that, according to Chalmers, is the easy problem.
Relatively easy, yes, explaining functions like memory, attention, decision-making in biological terms.
The hard problem remains. How and why do purely physical electrochemical brain processes produce subjective experience?
Exactly. Why is there an inner qualitative felt dimension to our existence? This qualitative feeling is known in philosophy as qualia. Why is there a specific taste of coffee, the specific quality of the color blue, or the inner sting that accompanies pain, rather than just a complex, non-conscious information processing system?
Let's try to illustrate this gap. The famous thought experiment called Mary's Room is perfect for this.
A classic.
So imagine a brilliant neuroscientist named Mary who is raised entirely in a black and white room and has never ever seen color. However, she has dedicated her entire life to studying the science of color.
So she knows everything there is to know about the science of color. She knows all the physics, the wavelengths of light, the retinal response, the neural pathways in the visual cortex, the precise chemical reactions involved. She has complete, comprehensive third-person knowledge of what happens when a human sees the color red.
But the thought experiment asks, when Mary is finally released from her black and white room and sees a red rose for the very first time, does she learn something new?
And almost everyone agrees.
Yeah.
Yes, she learns something new.
What does she learn?
She learns what it feels like to experience the color red. This new knowledge, the subjective quale, was not contained in all the physical facts she had previously accumulated.
That is the conceptual gap. The physical description, the third-person account of the brain, does not seem to automatically include or produce the first-person inner experience.
You can know everything about the machinery and still not know what it's like to be that conscious machine.
So the debate on the scientific boundary of consciousness, it really boils down to two main perspectives.
The optimistic view, first, which is often held by physicalists or strong naturalists, it basically posits that our current limitation is just ignorance. We're just ignorant of the correct physics or the correct computational theory.
So the optimist would argue that if we achieve a sufficiently advanced, complete scientific account of the brain, maybe incorporating quantum mechanics or some yet-to-be-discovered field theory,
then that explanation will necessarily include or just collapse into the explanation of subjective experience.
so the hard problem, they'd say, is only hard now, but it's solvable in principle.
Right. Conversely, you have the skeptic view. This view argues that the subjective nature of qualia may fundamentally resist capture by third-person measurement.
Why?
Because measurement, by its very design, requires objectivity and distance. The inner experience, the first-person view, is inherently internal and subjective. You can't be objective about your own subjectivity.
So if the skeptic view is correct, it suggests that reality contains dimensions, the qualitative, subjective nature of experience, that are just fundamentally inaccessible to the tools of empirical science, no matter how advanced those tools become.
It would imply a non-contingent limit, a place where the method simply cannot reach the thing it's trying to describe.
The problem of consciousness is therefore this intellectual battleground, where the limits of scientific description are most actively tested and debated.
And it forces us to ask whether physical facts are the only facts.
Okay, so let's move from the boundary of the inner subjective mind to the boundary of action and morality.
What we should do.
What we should do. This is the realm where the undeniable power of science intersects with the complexity of ethical choice.
This is the classic philosophical distinction, and it goes all the way back to David Hume in the 18th century. It's the difference between the S, the facts, the descriptive reality, and the values, the prescriptive mandates.
And science is superb at describing what is.
Unbeatable. But ethics, law, morality, they are all concerned with what ought to be.
So science gives us descriptive conditional facts. For example, if we increase carbon emissions at rate X, the global temperature will probably rise by Y degrees and Z coastlines will be inundated.
That is a scientific prediction about cause and effect. It's a pure is statement.
Science can also tell us that this specific neurochemical balance tends to correlate with feelings of empathy. Or policy A, based on economic modeling, is the most efficient way to maximize GDP growth.
All vital factual claims about consequences and mechanisms.
But I'll ask the challenging question, which is what the sources force us to consider. Can the scientific method, purely through observation and hypothesis, logically produce a statement like, we should reduce suffering even if it costs us economic growth?
Or, this action is intrinsically virtuous, independent of the outcome?
Can it?
The answer is no. And this is the core of what's called Hume's law, or Hume's guillotine. Science observes and describes nature, but it cannot derive intrinsic value from nature.
So just because certain behaviors are common in nature,
Let's say territorial violence or ruthlessness in competition.
that doesn't mean they ought to be embraced by humans as moral principles?
Exactly. You cannot logically transition from a set of factual is premises to a non-factual evaluative ought conclusion. There's a logical gap.
So we rely on science to provide the means, but the goal. The ultimate goal has to be supplied by something else, like philosophy or cultural consensus.
Science is absolutely crucial for informed moral decisions. It tells us the likely impact of our choices, but it cannot justify the ultimate goal itself.
Let's use a modern pressing example, AI ethics.
Perfect.
Science provides the capability. Researchers can engineer a highly advanced autonomous system for, say, military deployment or medical diagnosis. The technical capability exists.
But the ethical framework, the ought, has to come from outside the engineering department. The algorithm designers cannot use an experiment to determine if the system should prioritize minimizing human casualties, which is a humanitarian goal.
Versus maximizing operational efficiency, which is a pragmatic goal.
Right. They can only test which policy achieves which predetermined goal.
The moral input, the decision that says we should design the system to minimize bias against certain demographic groups, that's a value judgment.
And it's rooted in philosophical concepts of justice and equality, not a finding determined by testing the tensile strength of a circuit board.
So the relationship then is interdependent but separate.
Yes. Science is essential because it allows us to understand the precise consequences of our actions. If our ethical goal is to preserve the long-term human habitat, science is what tells us which actions are necessary to achieve that goal.
But the fundamental goals themselves, the ought statements, originate somewhere else.
Right. The premises like we should respect human dignity or we should conserve life are ethical axioms. We adopt them through philosophical reasoning or democratic consensus or religious revelation.
They are not discovered by measuring the boiling point of water.
Not at all.
So value and meaning are areas where science is necessary. You absolutely need the facts to make a good moral decision, but it is ultimately not sufficient to resolve the issue entirely.
It requires a non-empirical input to define its purpose and its ethical mandates.
The boundaries we've discussed so far, meaning ultimate existence, value, consciousness, these are highly charged topics.
Very much so. And for the listener, the intellectual posture you take regarding the limits of science is almost always deeply intertwined with your view of religion and metaphysics.
This is the great intellectual negotiation of the last few centuries, isn't it? How do we reconcile the undeniable empirical truth and authority of science with the profound search for purpose and meaning that faith traditions have provided for millennia?
And the sources outline 3 major models for managing this complex relationship.
The first, and probably the most visible in public discourse, is the conflict view.
This perspective holds that science and religion are fundamental competitors. They are both trying to explain the same phenomena.
They're rivals in the marketplace of truth, and one must eventually displace the other.
The classic historical examples often cited here are about cosmology or biology. Think of the intense cultural debates around Galileo's heliocentric model, or the battles over Darwin's theory of evolution in the 19th and early 20th centuries.
And the narrative is that every time science successfully explains a natural process, the need for a supernatural explanation shrinks.
This is often tied to the God of the gaps argument.
Explain that.
Proponents of the conflict view argue that religious explanations only survive in the gaps of our scientific knowledge, the origin of life, the beginning of the universe. As science closes those gaps, the space for God or the transcendent shrinks, leading to the expectation that science will eventually just replace religion entirely.
Okay, so that's model one, conflict. The second model is the separation view.
This was famously articulated by Stephen Jay Gould as NOMA, non-overlapping magisteria.
Magisteria meaning teaching authorities.
Exactly. This perspective argues that science and religion operate in fundamentally different, non-overlapping domains.
In this model, science focuses strictly on the empirical realm, the material composition of the universe, the mechanisms, the how and the what.
And religion, on the other hand, focuses on questions of ultimate meaning, moral purpose, and value, the why and the should.
So since they ask different questions using different tools, they can coexist peacefully without conflict. They just deal with different scales of inquiry.
This allows a scientist to practice their empirical craft without feeling the need to dismiss or affirm religious truths.
And it allows a religious believer to accept evolutionary biology or modern cosmology without feeling their core theological commitments are threatened. It defines the limits of science by mutual agreement.
Right. And finally, we have the integration view.
Okay.
This approach suggests that science and religion aren't just separated, but are two lenses focused on a single reality. Science reveals the detailed mechanisms of the world, and religion or philosophy provides the larger, overarching framework in which that science finds its purpose and meaning.
So they're complementary layers of explanation.
Exactly. This view often appeals to modern theologians who see scientific findings, like the vastness of the cosmos, or the fine-tuning of universal constants, or the complexity of biology, not as threats.
But as further revelations of an order, magnificent reality.
Let's use the example of death again to make this concrete for the listener.
Good idea.
Science explains the biological fact of death, the cessation of brain activity, the breakdown of cellular mechanisms. That's the fact, the is.
But the integration view would say that this fact doesn't negate the meaning. Religion interprets death in terms of spiritual transition, the possibility of an afterlife, or the revelation of a spiritual reality that transcends the physical body.
And both of those accounts are taken as true within their respective domains. The physical facts of biology remain true regardless of the spiritual interpretation assigned to them.
Understanding this spectrum conflict, separation, or integration is critical, because how you, the listener, choose to define the limits of science directly determines which of these models you're going to employ when you're dealing with all the information flowing from both empirical and spiritual sources.
It really shapes your whole worldview.
We've built up these various conceptual boundaries. Now, let's try to give you a practical intellectual map. A way to categorize the intellectual positions on scientific authority from maximum scientific confidence to maximum intellectual pluralism.
This should help categorize pretty much every argument you might encounter on this topic.
And it's important to see this as a spectrum, not just two warring camps. The disagreement isn't about the success of science.
No, everyone agrees on that. It's about what other sources of knowledge we accept beyond the empirical.
Okay, so at the far end, we have position one, strong scientism. This is that hardline view we defined early on. It's the belief that science, meaning physics, chemistry, biology, will eventually deliver a complete description of reality.
And that means reducing all phenomena from consciousness to morality to purely physical processes.
The strong scientism position holds that non-scientific questions about meaning, existence, and value are ultimately meaningless.
Right. If they can't be operationalized into a measurable variable, they're just expressions of subjective emotion or linguistic confusion. They dismiss non-empirical forms of inquiry entirely.
Okay, moving inward from that, we find position two, moderate naturalism.
This is a much more subtle and I think common position among contemporary scientists and philosophers.
And it states that science is unequivocally the best tool for understanding the natural world, and that we must always prioritize empirically verified knowledge.
The moderate naturalist acknowledges the conceptual difficulties we've been talking about, like the hard problem of consciousness or the difficulty of getting an ought from an is. They accept that science currently has limits. But they argue that these unanswered questions do not justify invoking non-natural, untestable, or supernatural explanations.
So the key differentiator for the moderate naturalist is a kind of intellectual agnosticism on non-empirical matters.
Exactly. They don't say the meaning question is meaningless, like the strong scientist does. They just say it's currently unknowable or untestable by the best methods we have.
So they advocate avoiding untestable speculation in favor of intellectual humility and just continuing the scientific inquiry.
Right. Next on the spectrum is position 3, critical realism or pluralism. This position goes a step further. It asserts that science offers a powerful, yet fundamentally partial view of reality.
So the pluralist accepts that other forms of human understanding are necessary to capture dimensions that science, just by its very design, doesn't aim for.
The pluralist grants science its full authority over the measurable world, but insists that disciplines like philosophy, art, history, and literature are not lesser forms of knowledge.
But are necessary for capturing essential truths about the human condition.
The inner life, subjective value systems, aesthetic truth, ultimate purpose.
So how is the pluralist different from the moderate naturalist?
The pluralist doesn't treat non-empirical truths as just untestable speculation. They view them as truths that are accessible through different equally valid methodologies like philosophical deduction or aesthetic appreciation.
So for the pluralist, the beauty of a sunset is an objective aesthetic truth, even if science can only describe the wavelengths of light.
Precisely.
And finally, we have position 4, religious or theistic perspectives.
This view fully embraces the methodology and successful findings of science, often seeing them as evidence of profound cosmic order, but it maintains a fundamental boundary that science cannot cross.
For the theist, science successfully explains the created order and its mechanisms. It operates within the bounds set by a greater reality.
Therefore, the method inherently cannot and should not replace questions regarding the creator, spiritual realities, the soul, or the ultimate reason for existence. Those answers, for the theist, come via metaphysics or revelation.
Mapping these 4 positions allows you, the listener, to recognize that the entire debate over the limits of science is fundamentally a philosophical one.
It's a debate about what constitutes knowledge, not just about the specific findings of physics or biology.
We've spent this time exploring some pretty conceptual terrain, but it's so crucial to reiterate that this discussion is far from merely academic.
Not at all. The answer to "can science explain all of reality?" has deep, immediate, practical consequences for how society operates and how you, the listener, structure your own worldview.
Let's start with education. How we define the scope and limits of knowledge directly dictates what we teach as authoritative truth.
Right. If we adopt strong scientism, then fields like philosophy, ethics, and theology have to be taught purely as cultural history, as descriptions of what people used to believe.
Not as genuine, ongoing paths to contemporary knowledge.
Whereas if we embrace pluralism, education must honor multiple forms of inquiry.
Second, look at public debate and policy.
This is huge. The concept of limits determines how much authority we assign to scientific claims versus moral or philosophical arguments.
When we're discussing policy, say, the ethics of genetic engineering science tells us what is possible, the I's.
But philosophy and our value systems must decide what is prudent or just, the ought.
And if we believe science has absolute authority, we risk allowing technical experts to make profoundly moral decisions by default, bypassing democratic and ethical deliberation.
It's a real danger.
And most personally, these boundaries shape our sense of personal meaning. Does the full scientific account, the one that describes us as highly complex, evolved machines governed entirely by chemistry and physics, does that satisfy our deep, innate need for purpose?
Or do we look for something more, something transcendent? Precisely because the scientific description, while accurate in its own domain, feels profoundly incomplete when it tries to describe the inner experience of love or profound grief, or the impulse to create beauty.
Intellectual maturity, it seems, requires a balanced approach, one that integrates intense respect with profound humility.
I think that's right. We have to trust science unequivocally within its proper domain, the measurable, the testable, the physical world. But we also have to avoid extending scientific claims beyond where the evidence actually exists.
And recognizing that questions of meaning, value, and ultimate reality require philosophical and spiritual reflection, which science can inform but cannot replace, that seems to be the central takeaway for the learner here.
Science is necessary for a comprehensive worldview, but it's not sufficient.
In final synthesis, then, science is an instrument of immense power. It's capable of prediction and control unparalleled in human history. Its capacity to model and shape the physical universe is just unmatched.
But power is not the same as totality. Recognizing both the boundless strength and the necessary limits of science is arguably the highest form of intellectual honesty.
And on that note, we leave you with this final provocative thought for contemplation, building on our journey through the limits of the measurable.
If the scientific method is inherently constrained to the measurable, countable, and observable, if we truly cannot use third-person tools to capture first-person truths, like the subjective feeling of color, does that mean these subjective truths are doomed to remain perpetually outside of verifiable knowledge? Or does the limitation simply challenge us to invent entirely new, as yet unknown methods of objective inquiry capable of finally bridging that conceptual gap between mind and matter?
Think about that until our next deep dive.